reflection is being able to inspect information about the program during the runtime. So you would be able to figure out what type a certain variable is, be able to change it even if you don't know exactly what type it is. So before I start off, reflection is often used very badly. So I'm going to start off with what you should not use it for. In a function, there may be a time when you use the empty interface to take any variable, and you want to accept multiple types, and depending on the type, you want to do something different. If you have a list of predefined types, you can use a type switch in order to avoid having to use reflection. So here is a little example. We're taking x, and depending on which case is used, it treats the variable differently. So if function f takes an integer, then you can just call it directly when in the int case. For the int slice case, we are able to index it as a slice and ignore the fact that it started off as an interface and we didn't know what type it was. Panics are bad, but sometimes it makes sense. Some people try and use it when they have many structs. They're normally trying to do some sort of inheritance or something where they have many structs and they want to get at a certain field name. What is best is to go with what Java and a couple other languages use, which is to just use a interface and use getters and setters. In Go, most often a getter won't have get in the name, but the setter will. So in this case, we've got the type foo, where we have name and set name. It's really annoying to do, but it's easier to check. You can take an interface which supports name and set name instead of just taking anything and praying that it's got a name field. So, what is reflection good for? Mostly it is used for marshalling, for taking data structures in Go and turning them into text to send to another computer. So JSON is a great example. And printf in Go is entirely written in Go. At runtime, it looks at its parameters and decides what to do instead of it being built into the compiler. So first type is reflect.kind. This is a very simple thing. All this does is tells you what you can do with the other types. You see, for example, if you had, say, something of kind slice, the indexing operations will work. You will be able to see what element it type is, etc. But if you were to say have an integer, it wouldn't make sense to index an integer. this is sort of like an enumeration. Go just does not have, enforced enumerations.
It's actually very powerful, the iota.
Yeah, iota, what this is doing is it's setting the first one to 0, and then everyone after that is +1. So, and it's also, using it of type kind, which is really just a uint.
The iota you can do also bit fields, so increment the.
Yep. Okay, so reflect.type is an interface that that implements a bunch of methods, some of which will panic depending on the type, so you have to check your kind. It actually goes on to the next page. there are so many, but it has different. It has information about types, not about individual variables, but about the overall types that the variables could be. So it'll be able to tell you the size of a type, if it what interfaces it implements, stuff like that.
Like the memory size of an object, so if you have any complex object, you can, on drawing time, you know how big it is?
It won't do a complex object. It'll really just tell you, same as like size of.
Alright.
And then one thing you will notice though is that a lot of things we think of by name, it thinks of by index. So something like trying to find a field, or you would need the methods used force you to give it a number, and it returns a method. If you have a method, you need to loop through the methods in order to find it. Using some sort of a for loop. Reflect.value gives you information about a value. You could say turn any type of integer into an int64. So I'll actually show some code later that does that. But it has many methods. One of the concepts behind the API is that functions and methods in Reflect panic all the time. The idea is that you should already know the type, so there's no point in returning an error. However, they always do document what types will panic, or give you a method that says if you call this other method, it will panic. For example, if you had some sort of an integer and you tried to set a uint, it will panic. So let's go back. So one of the things is that setting values is a little bit difficult, because when you pass a variable, by default, it isn't modifiable. You need to pass a pointer to it so that you can then use the set methods. So in this example, we're taking an integer, and depending on how you build the reflect dot value, if you build it from the variable or from a pointer to the variable and then dereference it with .elem, you get different answers for can set. So running it, so v cannot be set because it wasn't set from a pointer. And of course PV can, but both of them are of type int. Where's that? Yeah, here. So let's move on. Okay, interfaces. There's a little, I won't say flaw, but pitfall in the API where the API takes any variable with an empty interface. When you pass another interface, it's automatically converted to the empty interface before it's sent. So really what it is doing is it is showing you the concrete type. As far as it's concerned, it's always receiving an interface. So if you pass an actual interface, it won't know what to do with it. You won't be able to, see its type. So that is why you have to pass a pointer to it, because a pointer to an interface is different from a pointer to the concrete type. So when you dereference it, you get the actual type. So if we run this, the type of X, even though I said it was a type of interface, it says it's an int. While using the pointer method, it works. If I were to take this out and just do x equals 3, they're both int. Okay, let's look at some example code, because really the way to learn Reflect is to just sit down and read through that very, very long page and see all of the methods. But for an example, I'm going to use something called beEncode. beEncode is an extremely simple encoding that really only has 4 types. You've got, integers, byte strings, lists, which are just, arrays, Python lists, and dictionaries, which you can think of as Python dictionaries as well. So what we want to do is, let's say I'm making a torrent tracker, and I want to be able to take some arbitrary struct I have with peer information and send it to the client. Chances are I may have multiple things. I also need to send scrape data whenever they ask for it. It's not always announce information. So I want a generalized solution that I can pass any struct to, and it will turn into it will turn it into beEncode. So what I did was I just did a simple match of a byte string is a Go string or a Go byte slice. Int I said was any type of Go integer or unsigned integer. List I said was a slice, and dictionary I said was either a map or a struct. This is also what they do with JSON, stuff like that. So, bringing up the code. Is this big enough? Standard boilerplate stuff. Okay.
Can you use a lighter theme? Can you use a lighter theme?
Lighter theme.
Yeah, usually in presentation, dark ones are not so good.
I don't know how to change.
Probably in preferences somewhere. On the right.
There
use
we
preferences.
go, thank you.
Color scheme.
Yeah.
I think idle is yes.
Much better.
Yes. Hate the colors it chose, but whatever.
Yeah. At least for now we can see.
Right, so, pretty much same way JSON is set up. I created a encoder type which has which sends whatever it encodes to an IO dot writer, and then I gave it an encode method which takes, an empty interface, which is any type, and somehow serializes it into the encode. So there's a little bit of recursion here, but pretty much first thing I go through, I treat byte slices separately because I treat most slices as lists. But byte slices I decided should be treated the same way as strings. Someone else implementing it might choose differently. Note that this is not reflection per se, but when you do what this is called a type assertion, and you say, I know that what is in there is a byte slice, and the okay, is whether or not I'm right. But it won't work if, let's say, you had type, I'll just write it, which will be easier. If you had type byte slice byte, that would not be caught by this type assertion, because it would be a byte slice and not, it would be, byte slice written out and not a normal byte slice. Anyway, so yeah, this is pretty simple. We use reflect.value of in order to get the value we're working with. Then I did a switch on the kind so that, here's sort of kind of stupid. What I did was I just went through and looked at what it takes in order to call value.int. If you go, let's see. So it'll always tell you when it will panic and when it won't in the, I'm gonna say doc string because I cannot think of a better word. In the function description, it'll tell you what you need. In this case, it says that must be some sort of an integer in order to call value dot int. So here, I'm just checking for all of those kinds. And then I'm cheating and using fprintf. Fprintf is doing exactly the same thing that I just did. There's really no purpose. I can give it any integer and it'll work. But it's just a good illustration. Same thing with uint. You have to do that separately. String, just convert it to a string. For the complex types, I just pushed them off into other functions, except for pointer, which I just, call myself after calling .elem to dereference. Slices.
Hey, one question. Could you not have used like the type of to capture what you're catching as V? So you say reflect a type of V. That would not give you the type of instead of testing it for different types?
Well, I'm using type of, and then I'm doing a switch to decide which one to use. I mean, I need different code for different types. So,
But the type of gives you the type of, so you don't,
okay,
you already know what it is.
I am pretty much using type of. Okay, I'm using .type of the value, which is the same as type of.
Okay.
Just actually. Reflect type of x is the same as reflect value of x dot type.
I see.
So pretty much I'm just using here, I'm using value, which is the output of value of. And then I'm getting the type, and then I'm getting the kind of the type. And based on the kind, I'm doing a different action.
Okay.
In this case, when kind is a pointer,
I followed the rest. I was just wondering how you would get, if you already know what it is, then you just have methods that you can, oh, that's all right.
Right. Yeah.
So that's the same.
We pretty much do know the type, we just need the switch statement to pick which code to run based on the type. Okay, so for encoding the slice, can't use range unfortunately. Normally if it was a known type on a normal slice, you would just do for whatever colon equals range xs, where xs is the slice, and then do whatever. In this case, we don't have that, so we use v.len to get the length and loop over it like it was C. So length, if it was, say, an integer or a channel or something like that, actually channel len will work, or a pointer or something, then this would fail and panic, which is, one of the reasons why it panics so often is because in code like this, we know that we want the length of it because we know it's a slice. So it's easier to ignore errors. I mean, here, it's probably a mistake that I'm using v.len. It's probably like running it again and again and again. I'm not sure. It would probably speed up the code to only call len once. But I've actually done some benchmarks with this, and truthfully, once you start using reflect, things go really slow. One of the encodings called gob uses reflection in order to figure out how to encode something, and then it uses unsafe in order to do the actual encoding after it's figured out all the types. So that way it can go really, really fast, it just needs some initial setup. Mine is not that advanced, and in fact, most encoders aren't including JSON. gob is the Go binary type, so they felt speed was important enough. So anyway, the actual type of V here is a reflect dot value, and whenever we want to actually use use it, pass it off to something else, we have to call dot interface, and this will give us an interface value presumably like the one we gave it originally. Dot interface just returns whatever it is as an empty interface with whatever concrete value underneath, which was the original value. Also, in case you were curious on B encode and what this is actually doing, I wrote a bunch of tests while I was doing this. I was actually writing the test first and then writing the code to implement it. But pretty much for an integer, it's just I, number, and then the E. Strings, it gives the length of the string, colon, and then however many bytes. Let's see. Lists, it's an L, and then just a bunch of a bunch of items of any type. And dictionary, it's a D, and then a bunch of items where every other item is the key, and it must be a byte string,
So
and it should be sorted.
So it's only byte string keys.
What?
Dictionaries has only byte string keys. Okay.
Right. And they must be sorted. In order to accomplish, dictionaries, have any of you tried doing sorting at all?
Yeah, you need to implement the sorting interface and then.
Right. I don't know. Did we ever go over it?
I don't think maybe in the first or no, in the second meetup we
I
went
don't
through,
know.
but I hate it. I really don't like that you have to.
What?
Yeah.
That you have to implement all that thing for
Right.
comparison and like be able to sort something.
And the sorting is also kind of slow because of that.
I'm spotted by the sorted of Python.
Yeah, it's a common complaint in the Go news group, and basically they say this is the Go way of doing sorting, and
Yeah.
just live with it. There's no. The sorting package provides some convenience package like sort ints and sort strings and things like that, but mostly if it's your own type, then that's it.
Pretty much I just made, key value pair slice with all the methods needed to implement sorting. They implement the actual sort algorithm, you just have to tell it how to, swap values, stuff like that. And yeah, it's pretty simple code for writing. Places like here. What I'm doing here is I'm running, e.w.write, and then I'm checking for the error immediately. Error is not in the method scope, it's in the if scope. So error then disappears the second the if statement ends. It's just a slightly shorter way of writing. I mean, I could write that as 2 lines instead of 1. There's really no.
Yeah, the only thing is if you actually use the return value, which there you use an underscore, it's also valid only in the scope of the if.
Right.
So, and this becomes really annoying if you're trying to do a lot of things like that.
Yeah.
Then,
Can you show the code one more time? I just wanted to see what that.
What?
Can you show the code one more time? Yep. Just go down.
This code.
Oh, okay, I see.
If I was actually looking at anything other than the error, and I wanted it in the method scope, I would have to use two
Yeah.
lines.
Sorry.
So this, what I would normally do, is just take that out. And then it's that awful thing we all know of doing that and then doing, the standard.
and
error.
then you need to remember that the colon equal is just for the first one. All the rest do not need that because the error is already defined.
Right. But if I actually want.
Yeah, if you have another variable here, then yes, then you can do the.
Right. Okay. Then I guess maps, same thing. In the parent in code function, I figured out the kind was a map, perhaps after dereferencing and calling encode again. And it should be relatively simple. All it's doing is it's calling map keys, which returns slice of keys. It's ranging over that and building key value pairs. When it passes it off to write dictionary, it'll be sorted and then output. What's more interesting is encoding structures. Let's see. So pretty much same thing as the slice, in that instead of dealing with, elements that you normally consider numbered, we're dealing with fields, but it doesn't matter. You do the same thing where you just you just iterate over indexes. So in this case, for each index, we're getting the fields. I should probably find the field type that's being returned. It's returning one of these, which Okay, so it's being run on the type, so it's getting all the field information for that type only. And then it is checking the package path in order to decide if the field is exported. In Go, we know that something is exported only if it's got a capital letter. So, one of the important things with reflection is that you can never set a non-exported field. You are able to read it, so using something like second. It's very hard to do this without being able to see. So say using something like time, you can, let's see, printf completely uses reflection, and it can do stuff like print out exact Go code for creating types. So it's sort of like marshalling, like JSON or something else, except it can write out Go code or whatever else you need. So let's import time. So it has access to information such as, the number of seconds, location, etc. But it will refuse to modify it. So if you were to call can set, it'll say false because it is unexported. But it'll still let you look at it. So in this code, what I'm doing is, if package path is empty, the field is exported. So it is safe if I were to be creating a decoder later. That's actually why JSON will, the JSON package will not encode. Won't encode non-exported fields, is because it wouldn't be able to unmarshal it later, and it kind of sucks when there's a compatibility problem between what you can create and what you can then read back. So, let's see. So that's what this is for. After that, we need to get the tag. What a tag allows you to do is it allows you to give a piece of information that only a program using Reflect is able to get to. It's sort of like code comments for your program to read. So the common way to do tags, should probably bring up the info on the subject. So as it says, tag strings are are just text that contains normally your package name. So I would say, as an example, so I would say something like bean code, colon, and then I could put anything within those quotes I want to send to my program and tell it later. JSON allows you to put something, okay, the first one in JSON is always the name of the tag to use when marshalling and unmarshalling. So let's say you had X, well actually, this is not exported. So let's say you had name, but you wanted it to print as name. There we go. There's the second option. This is not in my simplistic, bean code, but in JSON you'd be able to say something like omit to tell it never to print it. It's up to whoever designs it what to do.
One thing that I noticed, those are backticks, so you can create multi-line of it. Okay, so you can like
Right.
that would be a whole file inside tagged with something for, I don't know, any kind of.
Yeah, I don't think there's anything stopping you from doing that.
And then you could do JSON comma, or you.
Yeah.
Something that I was thinking to use that is for validation, that you can tag it as say, okay, validate as int, validate as now, as phone number, sort of like how C# has
Right.
what's the name? Attributes? No. Well, you know what I mean.
Yeah, I can imagine
These
using it
attributes.
for checking that it's a phone number. That would be a great use of it. Let's see. So yeah, they have the reflect package. The convention on tags is not enforced, but they give you a function to make it very easy to use, and it will make you compatible with other things. So it's a convention that you're stuck with. So what I did was earlier I defined the package name was named bean code. So it'll get the stuff within the quotes. And then I just split on the comma as if I actually cared about what was after the comma. And then without any validation, which is probably stupid, just use that as the key when I'm appending the key values before I write to the dictionary.
So it's up to you actually to parse the tag itself.
Yeah.
Right.
Because the convention, usually I see it in almost all the encoded decoders, is something colon something.
Well, okay, that part is done by the reflect package's struct tag type.
Oh, okay.
That'll get the information within the quotes after the colon, and then
Yes.
everything from there you have to do the processing.
Okay.
So yeah, any questions or
Can you show the code again to handling the tags?
handling tags? It's down this way. Here, so what I did was I got the type.
Yeah.
From the type, I got the field. From the field, I got the tag, and then use .get.
Okay.
So it will just get bang like of the whole. If you do field.tag, it tag is a struct tag and has like a field, I don't remember now its name, that has the whole text. Okay, but then when you do .get and you pass the bank code,
Okay.
it will return only what's inside the commas after bank code.
Okay.
Right, so that way, if you also have JSON data, that would be, there would be a space, and then it would be JSON colon, and then whatever in quotes, and it would fetch that information while I'm fetching the being code information.
Do you have other slides?
Not really, I've just got, I can show you some of the stuff that's coming up in,
1.1?
yeah, 1.1 has a couple additions to Reflect.
Let me show some other things that I found.
On reflection?
On reflection, yes.
Okay.
So also, okay, this was all for Go 1.0.3. There have been many additions made. 1.0 came out a year ago, almost. So, if you go to tip.golang.org, you will get the latest information, and it includes some cool stuff like it has a select that will work with any number of channels, which truthfully, if you need that, you're probably doing something wrong. You're probably not doing things correctly, but for some reason they decided to add it. And there's also chanof, mapof, and sliceof, which if you were to pass to chanof a type, it'll give you another type, which is the channel version of it. So if you pass a string to it, it'll give you a channel for a string. So there are times when you might want to use reflect.new or whatever, and all you have is the string and you want to make a channel of it. I've never actually had this in practice, I've never run into this, but I'm sure that there are other people who have.
All right. Let me. Your code is online, right? Bank code. We have to put
Yes.
the
My
link to-
bean code is online at github.com/Stephen, STEPHEN, MW, and it's up there. I named it Go Bean Code, which I later realized looked like Goblin code, and I just never fixed it.
All right. One thing that I want to show is like small example of how to iterate over the arrays, like how we saw with Steven, and also like calling the method, sending and receiving on channel through reflect, and allocating memory. It's gonna be very like short example that I found interesting. These are the laws of reflection of Go. It's an article online that you can create from a reflection of, from an interface you can create a reflection object, from the reflection object you can create an interface, and it's what we saw dot interface from a value type, and then we can it must be settable, the type. This is what we saw, type and value, and the interface is always type and value together. One thing that it confused me at the beginning is, let's say we have a variable of type int, I use from C to just say, okay, type def my int from int. But then you declare a variable j and you try to assign from int to j. And what we get is cannot use j, type my int as type int an assignment. And it was so confusing. It was like, what? But-
and this is actually the same thing I pointed out with my byte slice, in that only something that was, brackets bytes would match, and if you made your own type based on it, it wouldn't work.
Exactly, and then like this is I create this like with reflect. I think I understood better what was going on. So I get the type and the of the int, and then I get the type of my int. Okay, and then if I run, I get E is an int of kind E, int, while the value j, that's my int, is type my int of kind int. Okay, and to get back an int from my int, I have to do this, or what else you can do instead of this? I tried to do j dot int, but this doesn't work.
No, okay, that's actually, you have type conversions and type assertions. Conversions are known to work at compile time.
Conversion.
Right, conversions. Assertions, which is
And
the
the
dot
conver-
whatever, so his,
This is conversion.
right, that is a conversion. We know
Okay.
j can be converted to an int, so we're good. If you had an interface and you wanted to convert it to an int, you don't know that the interface contains an int. You are asserting it, and at runtime, you find out if you were right or not. If you were not right, it either panics, or if you're using the two value one, it'll return false.
Is one some value and then the int.
Right, so some value would have to be some sort of an interface, and the type within the interface needs to be something that could not be known at compile time. So any concrete type, or it can be an interface that you won't know if the concrete type implements or not. So if you had an interface that was a reader-writer, and you wanted it to convert it to a reader, you would use a conversion, because a reader-writer is always a reader.
Mm-hmm.
But if you were going in the opposite direction, you would need to use a type assertion, because you don't know that it also has a write method. You have to test that at runtime.
We were talking with Steven about setability, and when you get a value, you have a method that you can test if can actually set it. Okay. So what we got? This is just an int, and the value of int you can set, because you here you are creating a copy of the int itself. Okay. While if you are doing this, it says also, like, I'm passing the pointer to it, but it says still it's false, because this v has value pointer to int. Okay, so you can't change the pointer to int, because that is the address of the pointer to int. What you have to do is what Steven showed us, and it's dot element. So you will get the pointer, we deference it, and that actually is the one that you can change. And then we can do dot set int, likely it doesn't go in panic because we know exactly what's going on, and we actually be able to set. And this is valid for everything, from structure, arrays, I don't know, channels. No, didn't try with that.
Channels, it's got some functions like send, receive, try receive, which
Mhm.
will be like doing a select with a default.
I have an example at the end.
Cool.
This is how you iterate over an array. Like, let's say you have this this array is very simple of integer, and then I have this function meta that accept an interface, anything. So, well, this function is broken because I have to assert that the I will do pt.kind and it will be reflect dot array struct. Then I'm sure len will not panic. And then I get from the value I get the value again at that index, and then I get the type. What is it? The interface gives me back the underlying value. Okay, so inside index returns a type reflect dot like dot value. But index while interface instead gives me back interface type. Alright. Iterate over maps is basically the same. We saw like map keys, Steven was using it, but then to get the actual value associate, you have to use map index. And then the same thing for to get the underlying value and all of that. Okay, so map keys and map index. Now what start?
Wait. One thing to watch out for though is that it expects reflect dot values. So you need in order to index the map, you need to pass a reflect dot value key. So when you do, map keys, it'll give you values instead of. Hold on, it takes values or interfaces? I'm
No,
not sure.
map keys returns an array of value or reflected value.
Okay, so then if
One,
you
yeah.
were to say have a key you wanted to test, you would have to call reflect dot value of before passing it. In this case, what he does later is, k dot string because the keys are strings.
Slices you can also do here instead. Here we get the pointer of our array. Now instead of doing dot element, there is this other function that does indirect, but basically check if it's if the value is a pointer and then calls dot element for us. But just in case you.
Is there any difference?
No. Well, no. Basically, you have the check of if the value is a pointer.
Fabrizio, I'm sorry, I have to leave. Do you have this code on the?
We're gonna post everything
You're gonna
online.
post everything?
Yeah.
Yes,
we're
I
gonna-
apologize for the need.
Are you parking inside or?
I'm outside.
Outside?
Thanks.
Then we call slice, and we can get like the sub value of that part. How do we iterate over a struct? Well, we saw that basically it's non-field and field, and then we go through all of them. And then we can see that there are name, package, path, type, get tag.
You need to use the information gotten from the reflect.type in order to define the field you want, and then you need to use the reflect.value in order to get the actual information for that field for that variable. So you can't just use one or the other.
One thing that you can check is if the field is anonymous, like in this case, like we just say that it's a string.
Yeah, I forgot how to access them after.
I think by position.
What did you say?
How do you access the anonymous field?
The anonymous field, how you access them? By position, right?
No, you access them by the name of the type, so a dot string,
Oh, the same as.
yeah.
No.
Like this, right?
I would probably just use println, yeah.
Yep. Nice. What if you have two? You can have two with the same thing, I guess, right?
You can, no, that
Or?
would compile error.
Well, I think that's a good thing about the meta fields.
No, now you're missing the one for the
So
initializer.
this. There we go.
Nice.
Yeah, you can't even have two different types of the same, I mean, if you wanted to embed a package 1.error and a package 2.error in the same one, that wouldn't work. You would have to do some sort of renaming magic, make a new type, or whatever.
So what we're trying to do here is to actually change a struct only by reflection. So that we have a structure with a...
Actually, I'm sorry, you could also do a embed the struct in another struct in embed, so you would
recursively.
yes, recursively embed so that you could change the type.
So we have this field n, and then we get the pointer to the structure to get to be able to be settable. And then okay, if the kind is a struct, we get the field by name. Okay, this is another way to get the field by the name of the field. Check if it's valid. Check if I can set it. If this is pedantic checking, but just to be sure. And then I set the integer to a new value, and from 42 it get changed to 7.
It is very common to call reflect dot value of on a pointer and then call lm after it on the same line. Just that's done all over the place.
So one thing that you also can do is like you have the type of an interface and you want to check the methods of the interface. Okay, but like I had a bit of struggle to find how I can get this type of an interface. Okay, and the trick is to do like this, like deference, like cast a nil element to an interface. You know anything better? This is basically I want the type without instantiate anything.
I went over this also in my slides and I just said pass pointer.
Pass pointer.
Yeah, I mean same thing you're doing.
Like this one without nil.
Yeah, I mean same thing.
Oh.
Well, no, you need a type of that.
No, yeah, but
Yeah.
I don't want to instantiate.
Okay,
Oh,
yeah.
you do.
In that case, you do it that way, yeah.
Okay, and what do you do? Here there is another for the interface. There is another type of reflect. We saw reflect dot type dot value dot struct field. This used reflect dot method for each of them. So you ask to the type how many number of methods that it has, and then extract by point. And the same thing applies package. Function actually returns a pointer to a function that then you can call actually. For example, this is how you call let's say person with person struct, and person has a method run. You say I want to run on this struct as the person.run. So in this way we reference this method, and then we just do call and we pass an array of reflected value of the struct.
Okay,
Bit verbose, but seems worked.
one of the things is when you reference a method like he's doing, it becomes a function where the first parameter is the receiver. So in this case, he's passing star person dot run. Its function signature has a pointer to person as the first parameter, and then all the parameters after that is whatever's in run, which there aren't any.
Okay, well, I wanted to try like how to create channels. And so we declare a channel, but we don't make it, no? Then we take the type and we create a channel with that type, and then I create with one so it's not blocking, and I can do send, reflect value. Send takes a value, not the exact, not E. That is something that confused me at the beginning. And channel.receive returns itself a reflect.value instead of the value itself. And once we get the value, then we have to call interface to actually get the things inside. So there is a lot of package and packaging.
I think the good lesson from this lecture is don't use reflection.
Yes, that is the best thing you can take away from this lecture. This
Well,
meeting
if you're
don't
doing
use it.
serialization, then
Yeah.
it's pretty unavoidable. But apart from that, it's really like if you need it, you really need to make sure that you really need it before you start using it.
One of the biggest mistakes people use is they try and use reflection when they're new to Go.
Yeah, and they're trying to do it because they want to have that the generic.
Right.
Generic, I don't know, but like C# with generics can do a lot of. I don't have to write so much code. Like here for every type, I have to really.
Because there's no generics and
And then I start to wonder if
there are a lot of discussions in the user group about generics. They're saying that they're not happy with any generics implementation that they saw. Not in Java, not in C++, not in other languages. So they're saying either we'll get it just right or we don't have generics. C's been around for enough time without generics, and you can still be productive. So
no. See, try to program an API in C, right? With so many strings and so many like.
well, every language is good for something and bad for something else. There's no language is good for everything. And Go, they said we wanted a system language doing a lot of communication and things like that, and there it really shines. When you start doing things like JSON encoding, which it's okay, but it's using reflection, it's not that great. And every time I do an API call over JSON with Go versus Python, the Go code is dog ugly.
I never really have a problem using JSON in Go.
It's not a problem, but you need to define
If you
exactly.
don't use it at all,
No, it's. So I wrote the Selenium package.
The what?
Selenium. Selenium is a web automation tool, so you can test your site on different browsers or just one browser if you want. And it has an API which is JSON based, and you need to write offhand a lot of structs just before you do anything. So in Python, just get the request object, get the JSON object, pick the fields that you want, and continue on. You don't have to beforehand just declare everything that you need.
Well, you don't have to declare everything, just the stuff you need.
Yeah, but it's more. In Python, just say, give me this JSON object, I want X from it, and
Makes
go on.
sense.
And so it's less code. It's less code in Python, but it's not that painful. And once I got the hang of actually anonymous structs that you say var equals struct something and just pass it to the JSON, you don't have to define all the type beforehand. It's actually become nicer, but still it's a hassle.
This is the last example of like how you allocate memory basically. Like this one creates like given a structure, this create a new instance of that structure. Another way to do it is reflect.0 that will create the default value of that type. And the difference between those two is that the first one returns a pointer the new one, the other one returns just
The type itself.
the type itself.
Are you able to, I mean, is the one returned by reflect.0 settable?
Good question. I don't know. Don't think so, right?
Isn't in pointer 3 already a value? You're doing a value of a value. That's,
That's bad.
just, no, just do in pointer 3 dot.
Concept.
Yeah. Just forgot the 3.
Let's see.
Okay, false. Okay, so when he's calling dot 0, he's not able to set it. So that's another big difference between new and 0.
Yeah. So basically, I don't know for what's the name? Null values. No, what's the name of null value?
Yeah.
Null value. When you create an object that you say, oh, is you create one object and is the object that is instead of inserting null, you create an empty object and you put it at the global space, and whenever instead of using a nil, use that empty object to say.
Okay.
Okay, that's what we got. I think we covered basically everything of reflect. Like that, this is reflect. Stay away from it.
Yeah.
But sometimes it's good to know.
Well, they tell people on the IRC channels the first rule of reflection is don't use reflection.
Reflect before using
Yeah.
reflect. No,
I'm going to start using that.
Yeah, we have.
Reflect very deeply.
Yeah.
So now it's just free talking about trying to understand how we can.
One more function in reflect we never mentioned was deep equals. Reflect has a deep equals implementation that will check, slices, maps, etc. and make sure that two structures are completely the same. I never end up using it, but it's there if you need it.
Is there anything in reflect for doing functions?
He actually did bring it up very briefly. You can call functions, you can figure out its parameters, its returns, stuff like that, using any function type.
We are listed in the official page of the Go user groups.
Cool.
Is there also a way to deep copy, not just deep equal?
No.
There is also a copy.
No, but deep copy. Not
Like in
just-
Python.
I don't believe so, no.
Yeah, shadow copy, it's easy.
I mean, you could make one.
Yeah, I can make
can't
one with
think of
reflect,
a
but
reason why not, yeah.
no, I was wondering if reflect itself has, if it has deep equal, if it also has deep copy.
One project that I want to write in Go is to have like like supervisor D. I don't know if you guys know. It's like for spawning a process and keep it checking that everything is running. That goes on top of init.
Someone did something which is similar, like an implementation of the Erlang VM in Go. And I think he had some, because in Erlang you have the notion of supervisor processes that they watch if someone dies and revalid. I don't remember exactly.
It was in the.
In the group, yeah.
Is that because Monet doesn't do what you needed to do, or just because you want to write something in Go?
Yeah, here. See Erlang this,
The issue
the
is.
third from the top.
Yeah, the issue with those.
Whoa.
Yeah, the distributed node in Go.
Because I want to have that single executable that I just put there. Boom, it works. You know, like supervisor did is a lot of things going.
There's a package called Monet that's pretty cool for that sort of thing.
I think I heard about it.
There's daemon tools also. I think.
I just
no?
use Rhino.
Yeah, but it's always like something that you have to install and.
Well, the thing is, what do you want? You want when something dies just to revive it and that's it?
Yeah, that basically process management, you know, like startup, restart, and I would like to have like a web interface of some sort of port. Imagine that you have like a cluster of these things, right? And you want just to restart because the code has been updated. So you want to download the new code and just say like restart to all of them.
So I wrote Seamless for web services or TCP packages, which is basically a round robin that you can change the nodes every time on the fly. So
Yeah, I remember Seamless is with dictionary, right? Like with it's the web part.
so Seamless is a TCP multiplexer. So you said these are the nodes that you multiplex request, and it does a round robin, and you can on the fly change which are the nodes. So you can replace the list of nodes with the new nodes and take down the old one. And then, but it doesn't supervise if someone dies, then it dies.
Yeah, but it would be one part of
Yeah.
the things.
Yeah, and you can do the same thing, by the way, with Apache and Nginx, that they have the same thing.
Should we use Nginx in front of a Go process?
But it depends what you want. You know, if you have one more layer of abstraction, you actually can take down and bring up services without interruption. Because, you know, you can bring a new one, point to the proxy to it, and then take down the old one. And you can't do it if this is the one that doing that. There's something called...
I actually recommend using Nginx for another reason, and that is keep alive timeouts. Go will just keep it open forever, and then you end up with many, many Go routines that are just doing nothing because someone an hour ago
yeah,
went to your website and
Yeah.
hasn't closed their browser yet.
yeah.
HA proxy is awesome.
On Stack
Yeah,
Overflow.
AJ proxy is good also.
On Stack Overflow, I think I'm up to 17 upvotes when I answered why he had all those
Yeah.
those
Yeah.
open Go routines doing
Yeah.
nothing.
So it's usually like you use AJ proxy Nginx, but usually put some kind of front end which is very dumb, just proxy stuff, but then you can replace everything underneath it without a lot of problem.
Because what I see in the cloud, at least the API service, everything is getting like I talked with the chief engineer of Netflix, and what he does is like when you have this big corporation, like you split the APIs in group,
Yeah.
and all the APIs have to talk with them internally. But then I think the same thing has to apply. You know? Like you have like the main load balancer, and then
Yes.
I guess right now it's HA proxy to everyone,
Yes.
and then you have like Nginx,
Yes.
and then you have your application code that can be PHP, Python, or Go.
Can you also in AJ proxy switch the backends of runtime? Tell it, you know. not
Yeah, you can
exactly-
pull things out, you can pull them out and put them in, yeah.
Yeah, and you don't need to shut it down or something.
No, you don't have to shut it down.
So there's
That would kind of make it not highly available.
Yeah.
If you had to shut it down in order to
But
switch your backend.
Is
to
there
its
like an
purpose.
API on HA proxy? to
Oh, you
do
know,
that?
proof and everything.
There might be, I mean, I've never had to go scale where I needed to do that, but I mean, there's I would assume that there is. I mean, I don't know.
I
but-
think you just have it reload its settings,
Yeah, that's what you do in Nginx as well.
hub or something.
Yeah.
Yeah.
Also with Apache. With Apache also, in both proxies, say Apache reload.
Apache makes a really crappy, I love Apache, it makes
Yeah.
a terrible proxy.
I never, you know, I don't have production experience with that.
It doesn't.
And for me, for playing out, I wrote the seamless one, which does the same thing in Go. So
Yeah, I need like I'm gonna try to
the only problem is with WebSockets that they're
fragile.
it's not fragile because now you need the service until someone closes all the WebSockets. You need it up. You can't kill it in the middle. That's a good thing about HTTP, which is, you know, one round trip and done, and then you can next one can go to another server.
Yes, you can kill it because you set up the client to reconnect if it gets
Yes.
disconnected.
But if someone if your front end people are nice and they do that, but if they just assume that the proxy is open and then that's it, then
That's not nice. You just tell the front end people
It's
that
a-
that's how life works.
It's a wild world. You never trust what's on the other side.
yeah, can never.
I was interested with HA proxy because Amazon Cloud, the AC2, now they added this new service that you can use Chef inside their system, and there are like recipes to bring up HA proxy internally.
Yeah,
And so that,
Kind of says something about ELVs, doesn't it?
yeah.
yeah. But DLBs are not that, they are meant for public access, right? Public access
when my
is,
ELB was sending it to someone else.
Yeah, well, they don't log, like, I am of the belief that ELVs are unusable, like, just don't bother with them. That goes for a lot, like, that goes for, I think, most things in AWS that came after the first year or two. Like, I mean, cause, you know, like Route 53, I'm totally allergic to.
yeah,
Why?
also that
Because-
one is.
what?
Why? I
Be-
actually find it useful.
Because the only control you really have in the end is your DNS. When things go bad inside AWS, the API goes away and you're left with no control surfaces whatsoever. So at least if you've got DNS, you can do something. If your DNS is outside Amazon,
Well, yeah, that's that is a good reason alone.
So you have a DNS outside of Amazon, then that points to one of the route. You totally skip Route 53.
yeah, you don't use, no, I don't use that at all. I mean, well, now I'm not even using AWS. I'm building an OpenStack cloud for somebody else. But when I was using AWS, yeah.
Oh, that's interesting.
I at one point made an ELB, and it was sending my traffic somewhere else, and I made another one and it started working, but I sent them an email telling them, and they're like, "Oh yeah, we found the problem." But that kind of scared me when it comes to ELB.
Because one of the lowest thing, like if DNS and routing doesn't work.
Well, ELB just, I mean, to my understanding, it still doesn't spit out syslog anywhere, does it? I mean, if it logged, that would be one thing, but really, like, all you can do is just like throw a bunch of requests and see how many make it back. It's like, oh, I guess things are working.
Or refresh the page and
Right.
see if you're reachable.
Yeah, I know people sometimes use Unbound or just caching DNS proxies. So
Unbound.
yeah, Unbound is something that you install. So it acts as a proxy to the DNS, but it caches the results. So if the DNS fails so you put it on your local machine,
Mm.
and then if the main DNS falls out, then you have the cached result, which is good and bad because sometimes you lose.
Inside AWS, I'll just put bind on every single instance and have
Yeah.
it slave, because
You know,
DNS is designed to handle that, so.
yeah, yeah.
Thanks,
Yeah, this one.
1970s or
Yeah.
1982 or whatever.
Yes.
I think Go 1.1 is coming out soon, right?
No.
No, I saw.
Well, if you look at the page,
I haven't heard
you know this page. Hold on, where are you? That's fine.
I think I saw one.
There's a page with all the Go 1.1.
Richard, you're not online? I don't
Is there
see.
gonna be like a Rob Pike Go book from Wiley with like pale blue text on the cover, or is that gonna happen, or definitely not, no one knows?
Nobody knows.
I doubt that they tell anyone until it happens.
Richard, I don't see you online.
On my. Well,
Search, swatch, Go 1.1.
Yeah.
We should be able to find the list of things that need to be done for 1.1
Yeah.
to come out.
Here, that one. Yeah. So these are the issues that need to go. And you see, it's not going down that fast. It's
yeah, the burn rate is pretty high.
yeah.
I know.
So I'm confessing one of them is mine, and I'm really slow in finishing it.
Because the process is not.
No, it's even before the process. You know, something that test suite is bugging me. I didn't find the time for that. So,
But like, I should take some of this. Assuming I'm good enough to even do this.
but yeah, and I guess when I get to the code review process, it will also going to bite me. So.
This seems like fun one.
What is it?
The syslog tests are flaky.
Okay.
How you know which one are being already working on? Like this?
No, there's something started by, but
Yeah, but there's something like mine, which I'm not a Go committer, so I have a patch there and I'm saying I'm working on it, but there's no indication it's actually. So
Well,
yeah, so I think it will take a while. They say they want it out this year, but
I just run, the latest tip.
no, I'm staying with one of.
Has anyone figured out how they're gonna handle packaging Go inside Linux distributions, since it doesn't use dynamic libraries? It wants all the libraries built into every package. Like, has that been
Well,
discussed, how that's gonna be dealt with, or?
I think every tool is gonna be just its own executable. Like they don't care. Like
There's
So
And I kind of like
mean
it.
the Go? You mean the Go development environment or a package written in Go?
A package written in Go.
Oh,
Well, a package written in Go, there's no reason to put it in the Linux package manager.
oh, there is because user wants it like that. They
Yeah.
want
Yeah.
they want apt-get something and to be done with it. They don't care that.
Well,
But-
instead you have to go get. The issue is that since we're not using shared libraries, there's no reason to standardize that way.
The reason is because user expect this behavior and user don't need to install the full Go development environment just to get a package that's written in Go.
no, they will not. Like, but
So if I wrote an
you're
executable
installing
with
something
Go,
already compiled,
yeah, so then
Like
that's the
then-
idea of packaging. So
Yeah, right.
I just want to
Okay.
do apt-get install whatever,
yeah.
and
Of
I don't care
course.
what's written.
I'm saying the reason is not technical, it's more of cultural, that people expect it this way. They want to go to the Ubuntu store,
that's what I,
click on,
but it's gonna be always one package without dependencies.
right.
yeah, but
Unless,
it's always-
unless there is something.
Well,
Well,
it's
but
not-
then the problem is that if people start writing things in Go, then those will become dependencies to other things.
No, because every source
Well-
package is unique.
Well,
Like
if
you-
if you've got something written in Go that's
No,
depended on by something written in Python,
it is,
then like
that-
if it's gonna be like if it's actually gonna exist in the Linux world as like a real language, like people are gonna have to figure out how to package it. Otherwise, it'll be like an also ran. Like,
it's just package. I don't understand what is difficult about packaging.
well, because all the dependencies get thrown in at once. So then, like, how do you?
That's a problem that at the moment cannot be solved. Is that every package would include all the everything that it statically compiles will just be included.
And that's why you don't see Java stuff in Linux distributions, because people are like, I'm not dealing with that crap. Like, it's just that's why.
I see
oh,
Java.
you see
stuff.
Java stuff.
You see, I mean,
Maven
yeah,
is
you do,
there,
but, like-
Ant is there, there's.
Sure, but like you don't see like
Eclipse is there.
you don't see like
Incident.
you don't see Linux people like, oh boy, Java. Like it's always like a pain in the ass and
Yeah,
sort
that's
of like
because-
a second class. I mean, it's a second class citizen in Linux.
Because of the dependency itself. not
because
right?
because everything's packaged that way, where you just like toss all the libraries
Yeah.
and package it in. Like that's just
But
like
it's different than Java because in Java you actually need to download different jars and adjust the class path. And in Go it's just one file, just throw it in and it's there. So
Only something external to Go, I see there might be
Yeah.
some issue because like you need to, well, the packager has to know exactly,
pack-
compile against a specific version of the operative system. That's
Which
It's gonna
is
be-
standard. I mean, it's like you do it with anything else. It's just that the one thing you cannot do is you cannot make a change to the TLS library to fix a critical bug and push out that tiny library to everybody. You have to push out every program that uses TLS.
Yes.
And that's a problem that I guess you could fix with GCC Go, but other than that, you really
Well,
just-
It's always, the
Yeah.
pluses and minuses using static linking versus dynamic
Right.
linking.
The only thing that's bothering me is the version of the source code that you are using. Okay, now right now I'm using, like, for example, Gorilla from master, but
Yes.
and then in my scratch instruction I write Gorilla from master. But
Yeah,
what if
so-
that
so
changes in
there's-
6 months?
There's several attempts at doing versioning for packages in Go. None of them is really catching on, I think. But
Because you have to clone the code and include that code inside your code.
and not necessarily. You can just install. So you can clone the code. Just do go install it. So basically, you clone the code, switch to the right version, do go install into Go. To then after that you can discard the code. You don't need it anymore.
But like if you want someone else, like imagine a packager that has to reproduce this exact
Oh, it's a
sequence.
packager.
And say, okay, master, which master? I download master, it doesn't compile, and then, but
Yeah.
I'm pretty much done, right? Who knows which one was the master at the time that I wrote?
Yeah, so that's something they know. I haven't seen any. There's a lot of talking about that. I see something called nuggets, right? There was nuggets. Someone said in the mailing list.
The issue is that there's no real dependency management and everything else.
But I think at least supporting like the hash, the shasum of the JIT version. I think in a file you would say go the GitHub / minsto / the package and then the hashtag of what version of that repository
Yes.
you are talking about.
Or
Well,
a tag or something.
There
Yes.
is an issue with that though, in that you might be including a package which also includes that same package you're including too, so it's also an indirect dependency as well as a direct one. And if you use different hashtags, you've just compiled two versions of the library into the same program,
But
which doesn't
that-
make sense.
Doesn't make sense, but it works, right? It's
This
a
is
big
what is
problem.
wrong with Java. This is what is wrong. No.
But the Java, the problem is that you have to download the 2 jars and then you have to deploy 2 jars and in Go once you have the source code and compiles.
And they may conflict with each other
Well,
if they both try and register something
Yes.
in another package or.
Yeah, in Java it's really I've seen it a lot. That in Maven what we started doing is download this package that exclude this dependency, and then download that package and include this one. Download this one but exclude that one, and
And you go into dependency hell.
yes.
Although then they built really awesome programs such as Maven and Ant, which you could spend hours learning.
no, that's over engineering.
with them.
Right? Like
From what I understand, Node actually has some nice dependencies.
Yeah, NPM's really nice.
Yeah.
Like it's absolute pleasure to
Yeah,
use.
I heard about it.
Yeah.
I don't know it, but I heard it.
Like how it works, like
So, basically in a project you have a JSON file, it's package.json, you list your dependencies. So you have so there's an npm repo, and when you do an install in your package JSON, it will put the name of whatever the dependency is, and it will put the version number. And you can specify either like that exact version number or something about it. So if the patch version changes, just give me the update, since it's
Yes.
probably not gonna be a big deal. If a dependency depends on on something else, each dependency has its own node modules folder. So you might be using underscore, and you might be including something else, like backbone that depends on underscore, and that's fine because you do get the same library included multiple times, but things are usually really small in Node. Let me see if I have something else. I feel like I'm not doing a very good job of explaining it, but
No, I think that basically
Yeah.
they have, each module has a dependency sub
Yes.
namespace,
Yeah.
right?
And,
So
Right.
where,
and you can specify when you import something, like a fuzzy matching of the version, if I'm understanding right.
right. So you have here. Alright.
It's a Chromebook.
Yeah, but I got a real operating system on it. Also, XFC. Yeah.
I always quit on XFC when I start using multiple monitors. Still not there.
Yeah.
Have you learned how to use XR&R just from the command line?
I give up. I go back to GNOME. At that point, I'm saying.
There's a nice little utility called AR&R that
Fonts?
creates configuration files for XR&R.
Just for.
you were searching for fonts once in the.
Yeah, I know, but it's
No, I know, it's like huge pain in the
yeah,
ass.
so
yeah, it's a pain, and also all the USB keys that you stick in, and I got spoiled by
No,
GNOME.
go on the page before. It
Was
the,
P-mount. You ever used P-mount?
Reference.
No.
So it's so you
You
can mount
go
as a
here.
user.
Oh, yeah.
And you
And
click
so-
font.
Yeah.
Yeah, but you need to explicitly mount. You can't.
You do.
So they have something which actually detects the fact.
That's true.
I know. I end up trying it out for a while, and after get pissed off and saying, you know what? No.
So, yeah, this is just the package JSON file, and in it you just, oh, I'm not in Tmux, it's not gonna work. So yeah, you include whatever it is that you want to include. The tilde is saying that if the patch number changes, just give me the update, because they're really good about using semantic version numbers. Most packages are anyways. And in there, people are watching, I forgot how to type. So there's the node modules, and this is where all the modules are. So Express will have a bunch of them. So like Express, for example, will have the node modules. And so this is everything that Express depends on. So that way, if you end up having two different modules that have different versions of different dependencies, it's not really that big of an issue.
And you just get it all. Okay.
Yeah, and if you want to solve something, like,
I like the anchor.
Yeah.
Prompt.
oh yeah. At some point, I realized you can throw Unicode in there, and just
Yes.
went overboard.
Yeah.
Anything worth doing is worth overdoing. Yeah, and we'll give you whatever you're searching for, and
The only bummer about this is that you don't really want to be deploying off of GitHub, especially.
right. So the npm repo is just a couch database. So you can, so there's a few ways of doing it. You can either just clone the couch database and just have your own private copy and tell npm to use your private copy and just constantly have it be updating. That way, if you end up running into a situation where there's like a
Someone rage kills their project.
yeah, so like screw this, I'm out. Or even something like there's a bug in a package, you can submit it to, you can just fork it and have it be in your private one as you send a pull request to whoever needs to pull it in.
Or some
And just-
random developer doesn't understand versioning, and
Yeah, like,
it was only out for half an hour.
right. Yeah, so there are ways you can do, like, there are, some people just like, just go with like, oh, it's on Git, whatever, it's fine. That's a version number, I'm not so trusting. But yeah, oh, and it's also per project, so, so there's no, well, you can have global installs of packages, but it's not really common.
I see. I like that. Like
Yeah,
when,
that's something I really like.
like every like you will build your when you build your package
Yeah.
.ia it will compile inside all the dependency that single
Yes.
package,
Mm-hmm.
and it will download all the files and everything. But basically when you do go build, the package path will be only underneath that
Yes.
path,
Yeah.
and the version can be with a tag on the Git or like the Mercurial.
Yeah.
So you tag it at some point, and either the tag or the hashtag that you want. I think that will work, cause
Yeah, I mean, well, what I end up doing for is basically just having a really simple like build script that will set the go path and just have some submodules.
Yes.
So that way I know that my dependencies are at the exact version, so if something changes and there's a breaking change later, that's fine.
so what
So-
explain it again, please.
Oh, sure, so. Okay, so. I basically, instead of just having the library, like have the entire project here, like source and package and bin and whatever.
Mm-hmm.
And, I just have Git submodules for whatever I want to, or whatever I want to include. And then that way, then like these are actually just forks that I don't really change of other projects.
Can you define tags in some modules?
Yeah, I mean it's just a Git SHA, so
Okay.
yeah, there's no reason it can be a tag. And yeah, so I just have this scripts build that will